So now I'm going to teach you some shortcuts. Let's start with the function f of x equals 3. What does the graph of that look like? So my grid, f of x equals 3 would be at 1, 2, 3, and it would be y equals 3. It's a horizontal line. So any tangent line drawn to that would still have a slope of 0. So that's one to know. If we have a constant function, derivative is 0 because the slope anywhere on that is 0. Now here's some polynomials, or polynomial kind of type functions. In other words, everything's just kind of added together in that nice little polynomial form. And I'm going to start writing down the derivative. There is a shortcut that I want to see if you can discover. So I have 3x squared minus 2x plus 3. The derivative for that is 6x minus 2. Negative 5x cubed is going to give me negative 15x squared plus 4x minus 3. I'm going to ignore negative 9x squared plus 24x cubed. Okay, got some negative exponents, but that's okay. That's going to be 2x to the negative 2 minus 6x to the negative 3. Ooh, fractions. Oh, that's all right. I can still do that. That's going to be a 4x to the negative 1/3 minus 8x to the negative 3. X to the negative 3/2 plus 3/2 x to the negative 1/2. Have you figured out what I'm doing? First of all, the derivatives of any constant I just seem to ignore. And everything else that had an exponent, I did really fast. This shortcut is just a mathematical thing for take the derivative. That's what it means. So this means take the derivative of x to some power. So what was I doing with all those exponents? Well, I was bringing that down in front and subtracting 1 from the front. Now when there was a number in front of the x, so that we had a coefficient, I was taking that and multiplying them together, and then subtracting 1 from the exponent. In order to use this, what's called a power rule, you have to have everything in what is called polynomial form. That means that it's got to be x to some power, and they all have to be multiple terms, added, and subtracted. Another thing is we want to write them all as x to some power. So there's some tricks that we're going to have to remember. So I'm going to write down some key things that we need to know. Like if I have a negative exponent, remember that just means 1 over a to the n. If you have a fraction exponent, that really means that you have the nth root of a to the m. Or you could do the nth root of a to the m power. But those are some things we're going to have to remember. We're going to have to take radicals and write them as fractional exponents. And then if we have our variable in the denominator, we're going to need to write that with a negative exponent. But then we're going to have to write them back the way they came from at the end, because we want to leave our answers with no negative or rational exponents. Rational means fraction. So in the first one, if I rewrite 2 over x squared as 2 times x to the negative 2, then we can use this new shortcut. Exponent comes down in front. So that's going to be negative 4. Subtract 1 from the exponent. Exponent comes down. Subtract 1. But we don't really want to leave it like that if it was given to us as a fraction. So I would rewrite that as negative 4 over x cubed minus 12x squared. So since they gave it to us in those terms, then we want to rewrite it as a fraction. Ooh, oh, we weren't supposed to have this. This is just crazy. Oh, why don't I divide everything by x? Great first start. So 3x to the 4th divided by x would be 3x cubed. Then we'd have minus 3x minus 2. Now I can use power rule. Remind me to play a song for y'all. There's a song about power rule. 3 times 3 is 9. Subtract 1 from the exponent. Now technically, that's a 1, right? So 1 times negative 3 is negative 3. And if I subtract 1 from 1, it's 0, so it's gone. And then the constant, that's technically x to the 0, so that's why you get nothing there. Ooh, I have to do something before I can do something there. I need to write it all out. It needs to be in polynomial form, standard form. So if I multiply these two together, I'd have x squared. 2x plus 3x is 5x. Plus 3 times 2 is 6. Times 2x plus 1. X squared times 2x is going to be 2x cubed. X squared times 1 is x squared. 5x times 2x is 10x squared. 5x times 1 is 5x. I'm distributing. 6 times 2x is 12x. 6 times 1 is 6. Now I'm going to combine like terms. 11x squared, that's a 5x and a 12x, and then a 6. Now it is in polynomial form. So we can use the magic of the power rule. 2 times 3 is 6, subtract 1 from the exponent. 2 times 11, subtract 1 from the exponent, plus 17, subtract 1 from the exponent, and I don't have one left. This is x to the 0, so 0 times 6 is gone. See how I can rewrite this one. Well, one way to do this, I could make that into x to the negative 5 in the numerator. And then distribute it. So when I multiply, I'm going to add the exponents. So that's going to give me x to the negative 2 minus 5x to the negative 3. Power rule. Multiply by the exponent, so that'd be negative 2, then subtract 1 from the exponent. Multiply, subtract 1 from the exponent. Now, they did not give us negative exponents to start with, so we don't want to leave our answer with them. So this can be negative 2 over x cubed plus 15 over x to the 4th. Ooh, that's a tricky one. Well, we talked about how that worked, so let's see, that would be 3x over x to the 2/3. How about we do kind of what we did here with the x to the 5th and bring that up to the top as x to the, equals negative 2/3 times 3 to the x. 3x. Not 3 to the x, we don't know how to do that yet. Multiply. Be 3. That's a 1. And if I add those exponents together, negative 2/3 plus 1 would be 1/3. Now I can use the power rule. 1/3 times 3 is 1. Subtract 1 from the exponent. It's going to give me negative 2/3. And if I rewrite that, well, I know that was negative 2/3 was x to the 2/3 in the denominator, which happened to be the cube root of x squared. This one's already in polynomial form. F prime is negative 3x to the, what happens if you subtract 1 from 3/4? Get negative 1/4. Multiply, it's going to give me 2 times 1/4 would be 1/2. X to the negative 3/4. Let's see, that would be over x to the 1/4, which is the 4th root of x, plus 1 over 2 4th root of x cubed. Now the last two things I'm going to do in the video, we'll do the rest of the examples in class. But we're going to actually prove two identities. Or I might put this in a separate video. I'm going to put it in a separate video.